Welcome to this new video in the mobile application series. If you're following the KDH course in mobile application development and data mining, you know that your next assignment is to create an MBAC game. If you're not following that course, I will still challenge you to create this game. But then here is a short recap of what this game actually is. The MBAC game is all about memory and attention. The user gets a sequence of stimuli, either visual or audio, and needs to remember if the current one matches the one of n steps back. When this is the case, the user has to click a button, and if it's correct, the user gets a point. By choosing the step of n to be bigger, the user can make it more difficult. Alternatively, a user could make a dual MBAC, in which case audio and visual stimuli are shown at the same time. It's a great brain workout, so also give it a shot yourself to boost your cognitive skills. Okay, now you don't have to create this application from scratch. I've already created a skeleton code for you, and this video is to get you up to speed on what that skeleton code does. So let's run through the folders that we have here on the left when we open our code. Well, first of all, we have our normal Android application code, containing a data package, holding a user preference repository, and a UI package that holds our screens, our view models, and our theme. Our theme is the default generated theme of Android Studio when we create a Kotlin project, so we don't have to look at that anymore. Then we have our application class. This is the actual class that holds all of our application data, and it doesn't do that much. It just specifies what happens when we create our application. We have our main activity, doing very similar stuff to the application, and we have our MBAC helper. What this class does, we'll come to in a second. Then we have our CPP module, having our C code. Now, if we look at the MBAC game, there is some game logic in which we publish events to the screen. If we recall the grid that we saw in the previous application, we need to define where the square has to be plotted and where a match has to be. Now, to make this game logic easier, we've already created a C class for you that creates a string of events, and we can define the number of matches that should be in this string and the number of combinations we want to have. So let's look at that code. Now, if we look here in our C code, we have the mbac.c, and this is the code responsible for creating that string of events. So here you see that our mbac create gets in a size, a number of combinations, a certain percentage of matches that you want to have, and the mbac number that you want to have. Now, this string is created by calling this create mbac string function, in which case we create a random number generator, and then we fill in the matches into that string, and then finally we fill in all empty positions. To test if this C class actually works, I've created a unit test. Now, what a unit test is, we'll talk about in a later lecture, physically in KDH Flemish Bay. But for now, all you have to know is that this actually tests the behavior of the C class. So what we do is we create, or we specify that we want to have a size 10 with 4 different combinations, a 30% match, and then a 1 MBAC. Then we initialize our MBAC helper. And what our MBAC helper does is it acts as a bridge between our Kotlin code and our C code. Now, in Android, this is something we have to do because Android cannot handle native C code. So we have to create a bridge like this. Now, back to our test. We then create our result string. We check that it's not null. If it's null, we'll fail the test. Then we calculate our expected number of matches, and then we check what our actual matches are. Now, we have given it a tolerance of 1, because in some cases we know that on certain sizes we would get a number of matches that is not an integer, which means that our C code can actually not generate that, because of course we cannot have half matches. Now we check if our number of matches, actual message, is within this allowed range, and if it is, we pass our test. So let's run this test, and when I have the result, I'll get back to you. Okay, our test has finished and we see here that the test is passed. Now if we click on the test, we also see our manual output. In this case, we see that the generated MBAC string looks like this, and it has 3 matches, which is exactly what we wanted. So our code works, and we can start to implement this into our actual app. So now let's look at the application that I've given you in the skeleton code. When you create your app, you probably want a home screen where you define the type of stimulus that you want to have. And for this, you will need some buttons. To represent this, I've already given you a screen with 2 buttons in the bottom. But right now, they only publish a small toast message that you click the actual button. So they don't really do anything. It is up to you to define the behavior of those buttons. Then here in the top, you see that a high score is being read out. Similarly, this behavior is not programmed yet. It's up to you that when a user finishes the game, this high score is updated, and when the user loads the application, you get out the current high score. Then here in the middle, we have a button that says Generate Event Values. And currently what this does is that when I press the button, a string is created just as in the text, and the event number is published to the screen with a certain interval. It is your job to attach this to either an audio stimulus, in which case each number should be represented as a letter, and formed using the text-to-speech library, it should be outputted to the user. The second type of stimulus is an audio stimulus, in which case you'll be asked to transform this number or event value that you get to a position on a grid. So you have to create a 3x3 grid, or a 4x4 or 5x5, depending on the combinations that you will have. So let's look at the code that actually creates this application. Well, first of all, in our main activity, we implement our theme. After this, we instantiate our view model using the view model factory. Now I'll explain this when we get to the actual view model. And then we instantiate our home screen with the view model we just created. Now, if you are going to create your app, you'll probably have multiple screens. So you have to make sure that you do a certain navigation as well. And that you could probably do in this screen. Our second class is our game application class. And I already told you very briefly that this is the class that runs first when we create our application. Now what happens is we initialize a certain user preference repository here. And currently this preference repository is not being used. You can use it to save your high score. So when we look at this class, all it does is it creates a data store, which is something we can use to save key value pairs. Now, as you can see here, we defined that high score matches with a preference key called high score, and we given it a certain tag. Now here we get that high score from our local storage. And what we see is that we try to get it from datastore.data. We try to catch it. Now, if there's an error, we send our error message to our log. Now, in this case, log.e means that when we go to our log cat, it is published under the level error. So if we filter on this, we see package mine, level error, and then we see the error here. In this case, it is not being shown. So we can actually see that we get our data store. Now then we get our preferences and we check if the high score key is in those preferences. If that is not the case, we give back a 0. Otherwise, we give back the actual high score value. Now, I've also given you already a function for saving the high score, which you can call in your view model. Now let's look at our game view model. Now for this game view model, I've given you an interface. And this interface states which values or functions we will have in our class. In this case, we'll have a state flow holding the event value and the type of game we're running. You can use this for updating your events or for whatever, and you can also expand this in your own application. Then we have a state flow holding the score, thus giving the current score to the screen. We'll have a state flow for the high score, getting the high score from the preferences and sending it to the screen. And then we have an integer for mback. We have 3 functions. First of all, we have a function for setting the game type. This function can be called by the buttons in our screen to specify which type of game we're running. And then we have a function for starting the game and a function for checking the match. This function basically checks if a match is actually happening when the user presses that he thinks a match is happening, and can thus increase the score. Now, when we look at our game view model class, we see those override for the interface. And then we see that we have a job, and this job is for having a coroutine. We then have an interval for the events, currently hard-coded to 2 seconds. We create our mback helper, and we say which array we'll use for the actual events. Then if we look at the game time function, we see that here we send the current game type to the game state. And then we have our start game function. Now here you'll probably have to edit a bit, but what currently happens is that we cancel any running games, any running jobs, and then we get the events from our model. We log it using the debug level. So if we go to our logcat again and we say level debug, we'll see all our debug messages here. And then we launch the job, so we run the game. And then based on the game type we've selected, we run a certain type of game. Now, as I said here, what you still have to do is that when the game ends, you have to update the high score, of course. Then our check match function is still empty. It is up to you to code a function that checks whether or not there is a match. And if there is a match, increase the score that you're currently having. Now, for a basic grade, you'll also need to run audio as well as visual. So here is the function for running an audio game. And then we have our function for running a visual game. Currently, what this visual game does is it just loops through the events. It sends the event value to the game state and then uses a delay to make sure that it doesn't just happen all at once. Now, if you want a higher grade, you're also asked to give the users a dual mback application, in which case sound and visual is run at the same time. Then finally, in this class, we have a companion object. And this object we use to create our view model. Normally, a view model cannot get parameters as input, and we need some sort of dependency injection. We have libraries for dependency injection like Dagger Hilt, but for now we want to do manual dependency injection, which means that we're giving our user preference repository manually to the view model. And for this, we have to edit the factory with which the view model is made. And that's what is done here. And then finally, when our code runs or when our view model runs, we also want to get the high score value from our local save data. So let's look at our Jetpack Compose for the screen. Okay, so our screen gets the view model that we just run through, and then it collects the high score and the game state from the view model. Now then we have a snack bar host state, and we need this to be able to publish those pop-ups that you've seen when we click a button. And then finally, we define a scope to run the game in. We then create a scaffold so that we can have this snack bar host, and then we create our column. So first of all, we have a text that just shows the current high score. Then we have a box, and this box currently holds this button in the middle. So this is what you'll probably want to change in your home screen. Then we have a text showing that we want to start the game and a row with 2 buttons. Now this button behavior currently is not linked to the view model whatsoever. So this is where you'll have to make your changes. I hope that you now have an idea which parts of the code you'll have to edit to make sure that your application starts working. If you've finished your application and you're following the course, then you'll show it to us in a presentation session. If you're not following the course, but you still want to show your application, feel free to send me a message on either GitHub or my email, and I'll try to get back to you and see if I can give you any commentary. Other than that, I hope to see you in the next video, where we'll dive into some new application programming concepts again.